Okay, so we're working on the absolute value equations. This is concept 30 for algebra 1. So there's two parts. We'll do the first part here, and then the next part will be in a separate video. So essentially, when we have absolute value equations, um, we are solving equations that look normal, they just have the absolute value symbols. And we solve them mostly the same way we solve normal equations, but uh, there's a little few uh, differences. So the first things first, the absolute value represents the distance of a number on a number line, a distance from zero. So um, when I have the absolute value of x is equal to 3, it's saying what number is 3 spaces from 0 on a number line. And it turns out we actually have 2 spaces. We have 2 numbers that are 3 spaces away from 0 on the number line. We have 3, so if I have 1, 2, 3 spaces from 0, and I also have negative 3, which is also 3 spaces from 0. So both of these numbers have an absolute value of 3. So the absolute value of 3 is 3, and the absolute value of negative 3 is also 3. So it's just saying that it's 3 spaces away from 0. Now, distance, when we measure it, it's not a negative distance. So even though we're talking about a negative number, as in the case of negative 3, when we find the absolute value of that number, it's always positive. So distance cannot be negative. Distance cannot be negative. And the absolute value of any number is always positive. It's always the positive number. So what if we have something inside the absolute value that sort of changes it? So if I have like the x plus 4 is equal to, x plus 4 in absolute value is equal to 10. It's essentially saying that inside this absolute value sign, we could have two options that would equal 10. So if x plus 4 was equal to 10, then the absolute value of 10 is 10. That's fine. We also know that if x plus 4 is equal to negative 10, then the absolute value of negative 10 would also be 10. And again, that's fine. So it's like x plus 4 can be equal to two things. Well, we can write two separate equations. We would say x plus 4 is equal to 10. And we would also say x plus 4 is equal to negative 10. So we have two equations that we can solve to get two different values for x. So that's a big difference between regular equations and absolute value equations. Absolute value equations give you two values for x, whereas most equations only give you one value for x. So we would essentially go about solving these problems by splitting the equation into a positive and negative version. So either what's in the absolute value is equal to 3x is equal to positive 18. 3x plus 6 is equal to positive 18. Or we have 3x plus 6 is equal to negative 18. So we would simply solve both equations and get two values for x. So in our example here, we would subtract 6 on both sides. It's kind of cool because both equations can be solved with the same exact steps in the same math. We just end up with a different answer. So 3x is equal to 12 here, and 3x is equal to negative 24 here. To get rid of the 3, I would need to divide. So I'm going to divide both sides by 3 on both equations. And x for this one is equal to 4, and x for this one is equal to negative 8. So we have two solutions. X is equal to 4 and x is equal to negative 8. The other ones are pretty straightforward. One thing you'll have to notice is whenever you have a situation where I have the absolute value of something is equal to a negative number, like negative 7 in this case, well, whenever I take the absolute value of something, like we said above, it's always going to be positive. So there's never an opportunity where you would take the absolute value of something and get a negative number. Therefore, this cannot be solved. So you would say it's no solution. No solution. The other problems on the notes will be solved the same exact way, and they look like that. Note here that it's okay to get a fraction. There's nothing wrong with that. It just means that x is a fraction, and that's pretty much it for the first part. So go ahead and take these notes, and then we'll pick this up in part 2, dealing with a little more complex version of absolute value equations.